This presentation is focused on Chapter 12 in the book Solid and Liquid Wastes. The objectives of this module and focus of the chapter are to describe trends in production of solid waste, methods for reducing solid waste, and how landfills figure into disposing of it, understand methods for wastewater treatment for primary, secondary, and tertiary wastewater or sewage treatment, how poorly designed waste and improperly processed sewage can cause health problems, and describe and define environmental justice. It's clear that when we have large volumes of waste, we have problems with disposal. Dump sites are filled. If we don't dispose of it correctly, pollution can get into our bodies of water like rivers and lakes. And often, people of color and poor communities bear the burden of our waste disposal practices. Municipal solid waste, often abbreviated as MSW, is trash or garbage. And in 2008, we produced, as the United States, almost 250 million tons before recycling. If you look at statistics today, this number is growing rapidly. The trajectory is per person, we're producing more waste, and as a nation. So as our nation grows, so does our solid waste production. What's in this waste stream? Packaging. How many people have received an Amazon package recently? Furniture, clothing. People often throw out clothing or find that it doesn't fit anymore. Bottles. Food waste is a major component of solid waste. Papers, batteries, and some other organic materials, like materials that might biodegrade. If you look at this chart, looks at proportionally how much of the mass is what components, and you can see almost half is food and paper. We've got yard trimmings, that would be an example of organic waste. Rubber, leather, textiles, again, that's like clothing. Plastics come in everything. It's both the bags, the bottles, metal, and glass. And this is before recycling. So what are the options for this? Recycling, going to a landfill, which is where the waste is buried. Composting, where you take the waste, often certain types of it, and help it break down more rapidly. Or combustion, basically burning the waste. In this figure, you can see all the different places that our solid waste goes. Can go from residential homes into a waste management stream to a landfill. It can be made into energy. Some of it can be recycled. Some of it can be composted. Some of these products, once recycled, can become new materials. EPA has a hierarchy or a strategy for waste management, and their first step in waste management would be to reduce the amount of waste by source reduction. So reusing products, not purchasing new, reducing packaging on new products. Recycling, of course, takes products that have been used and puts them into a stream to be produced into new products. And then, of course, least favored is disposal. Source reduction is the reduction of waste created, reusing whenever possible, and recycling when it is left. What is left? Waste reduction, total amount of waste produced by changing practices, and recycling, taking that material that's been used and putting it into other waste products, maybe producing new products. So in the United States, we have a lot of opportunities to reduce our waste. There may be reuse centers if you've ever tried to give away certain furniture. There are lots of centers like Goodwill or Habitat for Humanity that may take furniture if it's in certain conditions. You can send your food waste into home composting. Businesses have recycling. You see it around campus. There's drop-off recycling centers. If anyone's ever been to the DeKalb Farmers Market, there's a recycling center there. Or home recycling, where you put your waste out on the street like I did today, which is a Thursday, and it goes into a truck that gets shipped somewhere, hopefully sorted and recycled. EPA defines recycling as the process of minimizing waste generation by recovering and reprocessing usable products that might otherwise become waste. The most common forms of recycling in the United States are aluminum cans, papers, and it has been glass bottles, although recently I've heard that glass bottles are no longer profitable to be recycled. What are some of the benefits of recycling? It reduces emissions of greenhouse gases, which are the gases that are providing opportunities for climate change. It prevents pollution generated by new materials when we produce products. We also produce byproducts that aren't part of those products and can pollute our environment. It decreases the amount of materials that go to landfills. It can preserve natural resources, and it may open up new manufacturing jobs. It likely also save energy. Recycling rates have increased dramatically in the United States, and some programs require recycling but also cost, right? So we have to decide what's the benefit, how do we balance that? And many cities, like the city of Atlanta and other cities, now include a charge on your waste removal for recycling. Things that we recycle: paper, yard, aluminum cans, things that we should definitely keep out of landfills: tires, batteries, and plastic. There's growing evidence that we have so much plastic waste in the world's oceans that it's really harming wildlife and the ocean marine life. What's the composting? This is a microbiologic or biologic process that allows for the aerobic, which means it needs oxygen, decomposition of organic materials, leaves, grass, and food scraps. It produced a humus-like product, something that might be good to fertilize perhaps a non-food crop with, and it reduces the overall amount of material through this process. Its biodegradation is common, a natural man-made process, and during composting you accelerate it because you put in a lot of organic material. It can often produce a material that resembles soil and be used in gardening. Massachusetts has a successful composting program, and recently other states have enacted composting programs. It can prevent a lot of food waste from going into the disposal process, maybe saving more than $2 million a year in Massachusetts. There are actually programs around Atlanta. If you don't want to do home composting, they'll come and pick up your compost materials, probably for a small fee. Landfills, which is the last option that we want our waste to go into, are composed of four major parts: a bottom liner, so that material that gets liquid into that doesn't go into anything below that liner, like the groundwater; a system that collects those liquids; a cover, often soil or some other solid materials; and an appropriate location that minimizes groundwater and release of materials from the site. Landfills can be very large. They produce methane gas, and they can produce leachate that can contaminate groundwater. Siting of landfills also means that large amounts of trucks will be driving to the location to drop off waste, and there'll be constant truck activity, bulldozing, covering, maintaining the landfill. This is an example of a ground landfill. You can see key features are a liner, a well to monitor the groundwater to make sure it's not being contaminated, a leachate collection system that gets treated, and a ventilation system to capture methane gas. There's also a clay cap, and usually when the landfill is finished being full, it will be covered by some type of grass or some other vegetation. How does a landfill work? The bottom is lined with clay and sealed so that hazardous materials won't leak out. A liner holds in these toxic chemicals between the bottom and the last layer of trash, and it allows them to be pumped out through a sump pump. And then that leachate can be treated if necessary. Garbage is piled on rows. Bulldozers and rollers compact the garbage, and daily garbage is added. It's covered with soil and other materials, so there's continuous layering. After it's finally finished and covered, though, that garbage starts to undergo decomposition, and it's an anaerobic decomposition. The materials in that garbage that are organic, that will degrade with microorganisms present, will produce methane gas, which is a concern because it's a greenhouse gas and it's also very flammable. However, if captured correctly and used, it can be used to produce small amounts of energy. What are the dangers associated with landfills? Air and water pollution. The leachate may contain things like toxic heavy metals, solvents and cleaning agents, and gases such as methane are being produced. Methane, volatile organic compounds, and other gases can be emitted from landfills. Methane is vented purposely. It does pose a fire hazard, and it's a greenhouse gas, so often we do burn it to generate energy. VOC emissions, certain volatile organic compounds, could be potentially carcinogenic, and it could bother people's respiratory system. Megafills take in a large amount of trash per day, 5,000 to 10,000 tons, and serve regional needs. They can be more cost effective than incinerators, which is where you burn all of the waste to dispose of it. Federal landfill standards include restrictions on locations where landfills can be sited, material that the liners have to be made of, requiring collection of the leachate or the liquids that accumulate, monitoring groundwater near the landfill, and activities for closing the landfill and caring for it after it's closed, as well as corrective action provisions and financial assurance. Interestingly, there's a story fairly recently in the Atlanta Journal-Constitution about an illegal landfill, I think it's in South Fulton County, that has been on fire for weeks, if not months, and the residents are not happy about it. They feel like they're getting health effects from the air pollution, from the smoke, and it's unbelievable to understand how a landfill could have been started, let alone abandoned and burning under today's environmental standards. Outside of disposing of waste in a landfill, the other option can be incineration, where the garbage is burned, it generates energy, and it reduces the total volume of the waste. In this case, no trash is separated, and high temperatures can incinerate all types of materials. Metals from the residues can be recycled into scrap metal, and ash is deposited in landfills. However, burning garbage in incineration can produce contaminants into the air that can be hazardous to human health and the environment, and this can then get deposited onto the land or into water. Separate from municipal solid waste, there's a whole series of wastes that have to be disposed of in a different way, and these are called hazardous wastes. These are wastes that are not able to be put into landfills, and that they're regulated because you can't dispose of them. So hazardous wastes are disposed of by discarding them on the surface, storing them in ponds, dumping them into landfills or into the ocean, or incineration. Sources of hazardous waste include pesticides, cleaning products. These are things used in the home. Medical waste, if you've ever been to the hospital, products that are like radioactive materials, if they've done certain procedures on you, chemicals, other infectious agents, and then industrial waste, heavy metals from plating operations. If you've ever used any machines that have plating on them, often heavy metals are used to make that surface so that it doesn't rust. Toxic chemicals, like the ones we see for things like dry cleaning, solvents and residues from the manufacture of pesticides. So there's home hazardous waste. Electronic materials that you might have in your home can contain hazardous chemicals. There's medical hazardous waste, and then there's industrial hazardous waste. There's also radioactive waste coming from nuclear processing plants or from mining of uranium. And then there's mining waste that aren't specific to radioactive materials, but chemicals and heavy metals left over from mining operations when we extract materials from the earth. Hazardous waste can be a huge problem. It's estimated that hundreds of millions of tons are generated worldwide, and most of this is generated in countries like the United States that have developed economies. However, developing nations can often take this waste for cash payments, and this may be a huge problem. There's a number of stories about 5 or 10 years ago about e-waste or electronic waste, where the computers, all of the things you might dispose of, telephones, have components in them that are designed to protect the device from catching on fire, but are also hazardous waste. And those can get into this electronic waste stream, and many of our companies were shipping electronic waste to China, and then people were sifting through the waste trying to recover usable components that could be sold for cash, and there's a huge source of exposure. There's also recent evidence that even our non-hazardous waste, our recycling, which a lot of it used to get sent to China, that China's no longer buying that waste, and now it's becoming impossible to do recycling at an affordable cost. In the United States, we have an estimated 40,000 sites that have been contaminated with hazardous waste. They've been reported to federal agencies like the Environmental Protection Agency. Almost 15 or 1,300 of these sites are on what's called the National Priorities List. This is a list that the EPA generates that says that we're going to designate funds through Superfund, or the law is called CERCLA, Comprehensive Environmental Responsibility Compensation Liabilities Act, to clean up those sites. So even if the company that was there that left the contamination is no longer able to clean it up, there's a fund that enables the federal government to pay to clean it up. Many years ago, this is what hazardous waste sites look like. Uncontrolled dumping of large 50-gallon drums. But that's often not the case anymore. We don't do a lot of manufacturing in the United States, and we're much better at controlling this. However, sometimes when these sites were left, people had to go in and inspect the waste and determine what it was, and then send it to the proper place to be cleaned up. The impacts of these uncontrolled sites include adverse human health effects, very high cost of cleanup, reduction in property values, and even damage to the environment that might impact animals, plants, etc. If you've ever seen the movie or understood the story about Aaron Brockovich, that is a story of an electric utility company that was polluting groundwater with chromium-6 or hexavalent chromium. And there was recently a story published about that town that all of these things happened to it. There was a huge cost for cleanup. Basically, no one lives there anymore. The property values have been dramatically reduced. And of course, there was a class action lawsuit that Aaron Brockovich, the real individual, helped bring against the company that rewarded people because they did experience a range of human health outcomes. About 4 decades ago, what occurred in New York was called Love Canal. This was a former site of toxic waste disposal, and on top of it, homes were built, but it became very clear that the hazardous chemicals that were disposed of weren't disposed of properly, and people were being exposed to them, and it had harmful influences on their health, maybe sometimes long-term effects like cancers. And Love Canal was one of the main reasons that we built this law, the CERCLA, or Comprehensive Environmental Responsibility Compensation Liability Act, which is commonly called Superfund, because it puts together a bunch of funds that allow us to do cleanup. Medical waste is any waste that's generated in research or in treatment. This can be chemicals, it can be biologicals, and more than 3.5 million tons are produced annually in the U.S. Sewage is waste and wastewater produced by residential and commercial sources and discharged into sewers. And what's important about this is most manufacturing places that are using hazardous waste won't be discharging their hazardous waste into sewers. Many hundreds of years ago, if not thousands of years ago, people recognized that sewage needed to be conveyed away from towns and homes and people. And so the first evidence of sewer systems were from the Romans. And in the Middle Ages, there was a lot of regression where sanitary disposal of sewage didn't occur and people became very ill. But during the 1800s or the 19th century, there was a lot of innovation trying to understand sewage. This is around the time, if you think about John Snow was investigating cholera, we started to see lots of people living in densely populated areas. It's the Industrial Revolution in Europe and in places in the United States, mostly Europe. And what we start to see is that when people live together in dense urban settings, we have a lot of waste, and this waste starts to cause illness. And the important thing about this is that we start to understand that infectious diseases are being transmitted through this. Today, sewage treatment is quite modern and very effective and can almost treat water to A, better than the river it often gets discharged into, and sometimes B, to drinking water standards. But very few people want to drink water that's been treated from sewage. So the main technologies involved in treating sewage or wastewater are removing the solid pieces, inactivating the microorganisms. There's a high concentration of pathogens in this waste, and producing wastewater that can be returned safely to waterways or can be reused or recycled. In dry, arid environments, this water is often put back into the ground through groundwater recharge. In environments like ours in the city of Atlanta, where there's lots of rainfall and lots of surface water, almost all of the treated wastewater goes into a body of water. The first stage of sewage is called primary treatment, and large materials are removed out. This can then be composted or shipped to landfills. The secondary stage is called secondary treatment, and this includes microbes digesting organic material that remains in the sewage. They're present naturally, and sometimes we add actions to make them work better, but they do a pretty good job of digesting the material, and this is aerobic digestion. It reduces the content, it reduces a lot of the products that we don't want going into our rivers, like phosphorus and nitrogen, and it rapidly inactivates a wide variety of microorganisms. In the final stage of treatment, processing is directed at removal of solids and microorganisms, and ultimately this happens through filtration, charcoal filters, and sometimes chlorine or UV radiation. Here you can see a variety of different steps. There's a primary tank, a secondary tank. You can see aeration happening, and this is just how large these tanks are. Most jurisdictions require that at least secondary treatment happens, and water that has received primary treatment can't go to any common purposes like landscape irrigation. Only things that have gone through secondary, tertiary treatment can go to landscape. What else do we do? It's actually really difficult to pipe sewage. We don't ever use energy to push sewage around. We use gravity, but it's still complex, difficult to get sewage out of homes piped to a central wastewater treatment plant. And it works best in densely populated areas. And so when we don't have densely populated areas or the cost is too high, people choose other options. Septic systems are the most commonly used other option besides sewage treatment in the United States, but others may have things like composting toilets. In addition to humans and waste controlled by humans, we also have the possibility of being exposed to animal waste. Of course, biologic waste like microorganisms from animals are a huge concern, but also things that they contribute to the environment. They can contribute nitrogen or nitrates through their waste, and also cause algal blooms because of the organic material that they're contributing to water bodies. So nutrients, organic materials, microorganisms, residues of pesticides, all are associated with livestock, particularly concentrated operations of animals. And newly, although not that new nowadays, is the possibility that they are also producing antibiotic-resistant bacteria in the production of these animals, and that may endanger human health. So the last few slides for this set of talks will focus on environmental justice. What is environmental justice? The Environmental Protection Agency describes it as the fair treatment and meaningful involvement of all people, regardless of race, color, origin, income, with the development, implementation, and enforcement of environmental laws, regulations, and policies. It will be achieved when everyone enjoys the same degree of protection from environmental health hazards and equal access to the decision-making process to have a healthy environment in which to live, learn, and work. So the tenets of environmental justice are that everyone is at the table, they have a role in making the decisions, and everyone is equally protected. There is a long history of understanding why this movement came about, and it's associated with a variety of very important people that were activists. In the 1980s, a number of people were fed up with being overburdened with environmental health hazards, and this came out in a time period where a lot of laws were starting to be enacted, a lot more regulation was being put, and we were reducing exposures. But as a result of this, many communities felt that exposures weren't being totally eliminated, they were just being shifted. Most of the early protests were focused on stopping landfills, either hazardous waste landfills or municipal waste landfills, to be located in communities. And as a result, it became evident that there needed to be a document that described what was happening with these landfills. And the first product that came out in the environmental justice movement was a document put out by a church called Toxic Waste and Race in the U.S. And it examined location of hazardous waste sites and demographics. And it showed that communities of color and poor communities were often overburdened with locations of hazardous waste site or municipal solid waste disposal. As a result, in the 90s, there were two major acts. There was a summit, which was the first national summit for National People of Color Environmental Leadership Summit. And then in 1994, Bill Clinton, who was the president at the time, established the Office of Environmental Equity and Environmental Justice. 20 years later, the document was reviewed, and it was determined that we should relook at what has happened in this last 20 years in terms of our communities of color, our poor communities still being overburdened with these health hazards. And the key finding was, perhaps because of new methods, racial disparities are greater than previously reported in 1987. In fact, people of color make up the majority of those living in neighborhoods within less than 2 miles of the nation's hazardous waste facilities. And it's prevalent throughout the country. They underscored the urgency to find solutions to this problem. And so 3 key concepts in the environmental justice movement are disproportionate impacts, integration of civil rights, environmental law, and social justice, and community-based collaborative problem solving. This is from the work that showed how many people and what breakdown in the demographics live within kilometers 135 of a hazardous waste facility. And Separately, what we understand about the environmental justice movement is that populations are affected by both external and internal factors. That communities in these situations are facing multiple stressors and multiple hazards at the same time. There are social factors, there are environmental stressors. It's not just one chemical as a result. It's not just lead. It's not just TCE. It's lead. It's TCE. It's poor nutrition. It's job stress. And all of these make the environmental exposures and their outcomes on the population worse. The challenge for the environmental justice movement is that the concept about this and how to deal with these disproportionate impacts on communities is complex. And in the past, it's been a narrow focus attempting to solve problems. It's one site, it's one stressor, it's one chemical. But new approaches, particularly there's an entire field called cumulative risk assessment, focuses on understanding the relationships between socioeconomic status and environmental exposures. And a lot of that work is done through what's called community-based participatory research, where communities are engaged and participating in collaboration at every stage, helping disseminate the results and using that to leverage change in the communities. I'll leave these, we'll look at them in class, and we'll talk about them later.